much for being here. The floor is yours.
Thank you so much, Adam, and thank you to the conference organizers and volunteers as well for, first of all, for the invitation, and then secondly, for making sure that we all did get together eventually. I know you've mentioned that we would have loved to be together in person, but the silver lining to having delayed by a year is that my presentation is now called BC Energy Step Code 4 years in, and we have an extra year of data that we can share and give feedback on to the group today. So thanks for having me, and it's great to see everybody here. As Adam kindly said, I'm from Focal Engineering, and we're an energy analysis firm in Victoria, BC. I'm calling in right now from my laundry room. And if you hear little kiddos outside, I'll apologize for that in advance. So we do a lot of energy modeling. Like Adam mentioned, I'm on several committees, particularly involved in this energy step code. And we do what we term sort of research work. I know ABIPSA Canada has great representation from both industry and academia, and we obviously are here representing that industry group. So when I say research, it's not at the level of the academic folks, but we're really looking at how energy modeling can be put into practice. And that's really what I'm going to be talking about today. As Adam mentioned, I'm coming on 16, 17 years of practicing modeling here in BC, and I've seen lots of changes in that time. I remember when I first started, we had an ASHRAE 90.1 1999 printed copy in the office, and I think there were 2 of us who knew where to find it. And now ASHRAE is common terminology with electrical engineers, mechanical, architects. Really, the prevalence of building simulation has grown, which is great. And one of the biggest changes that we've seen, that I've seen at least in practice here in BC, is the step code. So I'm looking forward to kind of diving into that with everyone today. Adam went through most of the housekeeping items, but just as a reminder, if you're new here or if you just joined us, please type questions into the chat box. And if we have time at the end, I might go a little long, or I might hit right up against the 9:30 end. But if we have time, then we can address questions there. Otherwise, I have my email there and be happy to chat with folks afterwards. And in line with Adam, I did want to make a land acknowledgement and acknowledge the Indigenous people of all the lands that we are on today, calling in from across Canada. So for myself, I'm calling in from the home of the Lekwungen people. So a little overview of what we'll talk about today. I did want to provide a quick background and history on the step code, just to bring everyone up to speed. I'm not sure how many folks here are familiar with it. And also touch on some of the key metrics that are used in the step code, because they really form the bulk of the code itself. And then I want to discuss what are some of the notable changes that have occurred in the step code from what we were using previously. And then really the meat of the discussion is kind of what are the successes and challenges that we've seen as a result, and the impact on design and practice. Being on the step code committee, I know what sort of some ongoing work and some future work coming down, or that they shared with us. So I'm going to share that with you as well before wrapping up. Okay, so a little bit of a background to start with. This is just a quick timeline showing you the dates of the step code. So it was first introduced in April of 2017, so just over 4 years ago. It was part of the 2012 BC Building Code at the time. It was introduced as a revision to that code. And since then, we've seen 3 revisions to the step code itself. So roughly on an annual basis, kind of in the turn of the new year, we've seen 3 revisions, with the exception of last year. So the latest update we saw was December 2019. And I believe that we're anticipating another notable change coming at the end of this year, just based on some of the committees that we've been working on. So already we can see one of the kind of benefits of the code is being able to have that update on a more regular basis if that's needed in response to whatever industry is finding. Basically, it's a standard that's evolving quite quickly. As for the adoption of the code in the province of BC, I took a look at the step code website, and they listed 75 jurisdictions that are consulting on the code right now. So they're considering requiring it in their jurisdiction. And then 50 are already referencing the step code. Now, this is roughly a total. I tried to count once how many jurisdictions are there in BC, and it starts to get really challenging because of places like UBC, you know, that have their own building codes, and municipalities and regions and cities and townships. But I think there's roughly sort of 250. So you can see almost half already are considering or already using the step code. Now, the whole intent for the step code from the beginning was that it's a consistent way for authorities having jurisdiction to require projects to exceed base BC energy requirements. So if you can see my pointer here, just as a note, I'm showing right here part 3 energy compliance. So that's buildings that are basically not single family or duplex. And that's the world that our firm practices in more. I will be talking a little bit about part 9 in this presentation, but more often I'm talking about part 3. So just if that kind of comes up, if you're wondering if something's relevant, generally speaking, I'm talking part 3. So in the code, there's a section called Part 10, which is actually the energy efficiency requirement for these buildings. And there's 2 paths. One is to comply with BC, and that's either using ASHRAE 90.1 2016 or NECD 2015. And you can just do that as normal within those codes using either the prescriptive, trade-off, or performance methods. And then the second pathway is for exceeding BC, and that's where the step code comes in. And the idea was that before the step code was enacted, jurisdictions were able to create their own bylaws. Some had, you know, GHG requirements. Others said we mandate a certain percentage saving above ASHRAE. And there was just kind of a whole mishmash of energy performance requirements out there. And so what the government decided to do was create these different steps, and all of the buildings have step 1 and then steps 2+. And I'll talk more about the nuance between those 2 later. But these, as the steps get higher, the code requirements become more stringent, and so the jurisdiction can adopt whatever step they deem appropriate. And at that point, that becomes mandatory for any new construction building in that location. But at least it's going to be consistent with any other jurisdiction that has also adopted that step. So that's the benefit of the step code, is that consistency between jurisdictions. And then, of course, the other piece is that as the code improves along the way, we know basically where the BC is going. We know that in the future, they're going to adopt step 1 as the base step code. Step 2 will follow that, et cetera, et cetera. So ultimately, we basically have a clear outline of where the code is going as a pathway to net zero. Now, you may notice I put a little asterisk in here for step 1. It's kind of a gentler step than 2+. It basically requires an energy model under NECB 2015. It layers on some additional guidelines, and it also requires airtightness testing. That's kind of in a nutshell what step 1 is, where steps 2+, those actually introduce new metrics that I'll be talking about shortly. So what does this look like? So for part 9, as I mentioned, there's always this kind of step 1, and then 2, 3 for part 9, these are considered lower steps. And then steps 4, 5 are the more challenging upper steps of the code. So for part 9, single family residential and duplex, those have 5 steps. For part 3 residential, so for larger MURBs, in that case, we have a 4-step step code. This is supposed to get us, again, to net zero energy ready by 2032. Like I said, we've got the base building code in step 1 roughly being equivalent, and then we get better above that. And I wanted to mention as well, the code also introduced the option of passive house being an alternative to the highest step of the code. So whether that's step 4 for a part 3 building or step 5 for part 9 building, passive house is considered equivalent to the highest step. So if your building certifies for passive house, then you will pass code as well. So I've mentioned a couple of different building types and how they have different numbers of steps. And so I just wanted to outline the applicability of the step code as it currently is. First of all, group C residential occupancies. So these have 4 steps, and they're broken into 2 different categories. So if you're building a hotel or a motel, then those have one group of requirements. And the only thing that changes between that and the other residential are the actual values of the limit, the requirement. And I'll talk about that in a second. So there's one group for hotel, motel, one group for other residential, MERBs, student housing, that kind of thing. Group D major occupancies are also included, so business and personal services. There's a category for office and then other types of services, and those have 3 steps. Group E mercantile or retail have 3 steps. And then in the last revision of the code, they added this group as well. So it's roughly speaking, group A, B, assembly, treatment, and care occupancies. If you think about it, these are basically public sector facilities. So schools, libraries, colleges, rec centers, hospitals, and care centers. These all require step 1, or these all have 1 step available under the step code. So there's no limits associated with these buildings yet. If a jurisdiction wanted to say our school should be step code, then they can only apply they can only mandate that they be step 1, which requires the energy model and the air tightness testing, as I mentioned earlier. So this is the current applicability of the step code. And so the next section gets into what are those metrics that I was talking about for steps 2+. What are the actual limits that are required for those buildings to meet? So this slide just gives you a quick overview of the limits. As you can see, we've shown in this table the Part 9 tightness in the top row and the Part 3 limits in the bottom row. And for each of Part 3 and Part 9, there's an air tightness testing requirement. There's a requirement for equipment and systems to be efficient. There's a building enclosure requirement. And then for Part 3 only, there's an overheating requirement, so as related to thermal comfort. So I'm going to go through each of those individually. I'm not going to spend too much time on them, but I do want to make sure that everyone just kind of has a base background in them in case you haven't seen these terms before. So we're going to start out with the building enclosure requirement, which is called TEDI, or thermal energy demand intensity. I realize I didn't define that anywhere here. One of the things as modelers, the word demand relating to something that represents energy consumption was something we pushed back on from the start, but we didn't quite get our way there. So thermal energy demand intensity refers to the delivered heat, so the annual kilowatt hours to the building. So it's a balance of losses and gains for the building. The one kind of misnomer in it being a envelope metric is that it also includes heat recovery. And I'll show you what this looks like in just a moment graphically. That helps describe it a little bit better. So it's determined from the energy model, and it's basically, if anybody's familiar with passive house approach and the space heat demand, this is basically the same calculation. It kind of grew out of the passive house approach. So like what I mentioned before is that it's the net of the losses and the gains of the building over the course of the year. So if we look at primarily our ventilation losses and then envelope infiltration and conduction losses. So this is our losses column. And then on the gain side, we look at our heat recovery and then any sort of internal gains, whether that be mechanical, fan heat pickup, plug loads, occupant lighting, solar gains. Those are all tallied on the gain side. And then the heating load, the TEDI, is the net between the losses and the gains. So that's defined here. And the TEDI is, this is an example that I've given you. I didn't put any numbers in, but it's from a step 2 MERB. It is relevant for both parts 3 and part 9, and they're calculated the same way. The next metric, this is the part 3 one, and it's the TUI. It's the total energy use intensity. I think as modelers, we're all pretty familiar with the EUI. Basically, they added the T on the front. And so we talk a lot about the TUI for part 3 buildings. For part 9 buildings, they adjusted that metric somewhat. And instead of the TUI, they landed with the MUI, the mechanical energy use intensity. So this is again an output directly from the HOT 2000 energy model. I say HOT 2000, although Part 9 does allow for other modeling softwares. However, I think it's fair to say that HOT 2000 is most frequently used for these types of energy analyses. And it's similar to the TUI, but it doesn't include, it only focuses on the mechanical end uses. So, service water heating, fans, auxiliary, and space conditioning, no lighting, no plug loads, etc. So that's the MUI that is being looked at in Part 9. However, Part 9 does also have an alternative to the MUI. In lieu of achieving that requirement, you could also demonstrate a percent better than a reference house. And that is, again, something that comes out of the software. HOT 2000, again, will generate that very easily. Other softwares may require a baseline model or a reference model in order to generate that percent savings. As I mentioned, there is an airtightness requirement for parts 9 and 3. So all buildings now have to be tested to determine their level of air leakage. And they do have different requirements between parts 9 and part 3. So I've just summarized a few of the key points here, but of course they are very detailed requirements for how the tests need to proceed and how the results need to be presented. One of the key ones for part 9 is that it's tested at 50 pascals. And I mentioned it because it's different from part 3, which is tested in accordance to the standard ASTM E779, which is tested at 75 pascals. So there is that initial difference just between the two right there. And the part 3 one also requires positive and negative testing and an averaging between the two. So that's kind of another key difference. In addition, the step code tells us that during design, before we have an actual tested value to put into our energy model, we need to carry a certain infiltration level, and so that's recommended to us by the step code and associated documents. And then this is really one of the key elements to the step code that I'll talk a bit more about later. I'm still just kind of introducing the metrics, but it requires that for steps 2 and up, the post-construction airtightness test result needs to be put back into the model. And then at that point, if either your TUI or your TEDI fails, you need to tighten your building and retest. So technically, a jurisdiction could withhold occupancy if you fail during your airtightness testing. And that's, of course, really significant because not only are we waiting until the end of construction to test, and so it's something that the modeler has to be brought back in at that point to revisit. The other piece is that usually your airtightness is something that's your air barrier is sealed up underneath cladding or drywall, and so it can be really challenging to try to tighten the building at that point. So it's having some implications on scheduling and such. As I noted, for part 3 buildings, there's also a new overheating limit, and that is for passively cooled buildings or passively cooled spaces within a building. The way that this requirement is laid out is that there's a maximum temperature limit for the summertime months, and this is dependent upon the climate file. And the indoor temperature of a passively cooled space can only exceed that limit for 200 hours of those months. That's the code requirement is 200 hours. There's also a recommendation in there to actually lower that limit to only 20 hours for vulnerable occupancies. And so some developers, some owners are choosing to adopt that lower vulnerable occupancy target across the board as well, such as BC Housing. All other projects require only the 20-hour limit to be met. I won't go into details on the calculation, but it's defined in the Vancouver Energy Modeling Guidelines, which apply to the step code. And it has roots in ASHRAE 55, and then it was kind of updated to suit the step code. So just giving you an idea of what this looks like, here's an example for the Victoria, BC, and this is using the CWEC 2016 climate file. So in gray here, we have the outdoor air temperature plotted. And then in blue, these are the resulting overheating temperature limits as a result of this climate file. And then this black line is the indoor air temperature for one space that's passively cooled within the building. And then we count the hours that the internal temperature exceeds those limits, and that is that 200-hour limit that we need to achieve. And so for each of these metrics, for the TEDI, for the TUI, for the MUI, basically what we see is that as we get into higher steps in the step code, the target value, the requirement that needs to be met, it gets more challenging. And so that's what I'm going to talk about next, is that as we move to this target-based approach, what are some of the bigger changes that we've seen to the energy model and also to the process of modeling? So first of all, like I was saying, in the target-based approach, now the targets that we get are basically based on each climate zone. And in BC, I know that everyone thinks of us as the sort of California of Canada, and it's true, it is warmer here in the winters, but we do actually have climate zones 4 to 8 in BC, and so we are able to, and so we do have requirements all the way up to, they're generally up to climate zone 7+. And so as you get into colder climate zones, the targets change, and then also as you get into higher steps, the targets will drop as well. But of course, this is different from the older approach of having a reference building, because in that older approach, you had a unique reference building to your specific project. So if you had a 50% MERB and 50% office for your proposed building, then you had the same in your reference building. Whereas in this case, you know, we've got these unique scenarios that kind of crop up, and what the code found is that they had to add in sort of adjustments to help account for some of these unique scenarios. So I want to start out by talking about some of the adjustments that were either introduced from the start or introduced in some of those revisions that I was showing you as the province learned that you know, we needed to update the step code to make it a bit more relevant. So the 4 adjustments I'll talk about, one is for part 9, and that's actually adjusting the TEDI between heating degree days and climate zones. And I'll show you that in a moment. The next 2 have actually been in there from the start. These are part 3 adjustments based on quarter pressurization and submetering. And then the last one is how to address mixed use buildings. So for this part 9 TEDI limit, basically what they did was, instead of just saying, if you're in climate zone 6, here's the TEDI you need to achieve, they basically said, we're going to further adjust that TEDI based on the heating degree days of your exact location. So, you know, climate zone 5, for example, is heating degree days from 4,000 to 4,999. So that's quite a range. So what they've done is basically linearly interpolated between them, so that the ones on the higher end have a higher TEDI budget than ones on the lower end. And I'll just show you an example of that in a moment. So they follow along with these equations. If you're in climate zone 4 or climate zone 8, then you follow one of these 2 calculations, and then anywhere in between climate zone 5 to 7, that's where there's that kind of interpolated value. So this is an example. Here we have 2 locations in climate zone 5. Whistler has got heating degree days of 4180, so kind of on the low end of that climate zone, and McBride has got 4980, so almost bumping up against climate zone 6. Now the original step 2 TEDI limit for both of these was 60, so that was just a base requirement across that climate zone. Applying that calculation that I've shown you updates the Whistler. It gives it a slightly bigger budget of 63.6 kilowatt hours per meter square per year. McBride, however, gets quite a bit higher, up to 79.6, which, as I mentioned, is almost the climate zone 6 limit. So you could argue this is a lot more fair. I'm going to show you a little bit another side of the argument later on, but this is kind of watering down the step code. But as it stands, this is the this is what is allowed under the step code based on those adjustments. The next adjustment I wanted to mention is corridor pressurization. So this allows for overventilation in MERB corridors, which is local typical practice here in BC, really to prevent smell migration between suites, just pressurizing those corridors so that you don't have ventilation air from one person's unit going into another. So again, I'm not going to go into the details of the calculation. That's all defined in the Vancouver Energy Modeling Guidelines. I've noted the section number there. But it limits the adjustment to a value of 10 kilowatt hours per meter square per year. So when we're talking about higher steps, Teddy of step 4, the requirement is 15. That means that if you have an adjustment of 10 on your building and your result comes out at 24, you could actually pass that Teddy of 15 because you're able to subtract this adjustment of 10 from your 24 result. So you could actually meet your step code requirement in that case. So as you can see, this can have quite a big impact on these higher steps, especially. And I guess the nice part about this, though, is that by setting the limit out now of 10, they've given this basically this big buffer. The step code in any subsequent revision can start to sort of pull that back as new design techniques and strategies become available, and buildings, and designers find ways of reducing the corridor pressurization or maybe preventing smell migration in other ways. So it's kind of nice by introducing these adjustments, they still have the ability to learn and then to update them as they go along. So I think that's one of the real benefits of the step code, is that ability to kind of follow up. I also mentioned that there's this part 3 adjustment for submetering. And so this is for any residential building with central hydronic heating. And it comes out of a research project from the city of Vancouver from several years ago, where they looked at buildings where occupants pay their own utility bills versus when they're billed on a square foot basis. And what they found was that if you're just billed on a square foot basis, you tend to use on average 15% more heating energy, just because you're not getting that feedback loop, obviously, on your cost side. And so what they've said is, look, if you're building this kind of central system, submeter the heating water at each suite so that individuals can be billed off on their usage. Or if you're not going to do that, then you need to add 15% to your heating energy on your TUI. So it's only relevant to the TUI under the current guidelines, but you can see it could make a difference if you're approaching the limit. And it's basically if the developer or the owner doesn't wish to pay the upfront cost of individual submetering, then they need to take that penalty instead. And this is another metric, another adjustment that is defined in the City of Vancouver modeling guidelines. Sorry, my mouse seems to be stuck here. All right, here we go. The last sort of adjustment that I wanted to mention was that example that I sort of introduced at the start. What if we have multiple occupancies, and of course, at least one of them has to be step code in order for these guidelines to be relevant. So what the requirement is for modeling is to blend the limits between different occupancies. So one of the more frequent archetypes that we see is, mixed-use residential, several levels of apartments above some retail space or maybe office space in some sort of, city. And so those basically based on the floor area, those limits need to be blended, and the project as a whole has to meet those. It gets further complicated though when we have non-step code occupancies. So if you have a warehouse building, let's say, which doesn't have a step code requirement, it wasn't in that original application list that I showed you of major occupancies. And if you have a warehouse building with, say, an office component, and the office does have step code, then you need to do a little bit of modeling under both scenarios. So your office has to have a step code model, and then your warehouse portion needs to use the reference building approach. So currently that is allowed under either ASHRAE 90.1 2016 or NACB 2015. And that reference building is then used to determine the reference TUI and TEDI limit, and that's now blended with your office limits, your step code ones. So it can get a little bit more convoluted under those types of scenarios. There are a few other sub requirements in there. So for example, this one here, the step code occupancies need to meet the TEDI value. So like that example I gave you between the warehouse and the office is going to have a more stringent TEDI requirement or likely. And so if the warehouse had a sort of a poorer one based on that reference building, the office still needs to meet its own step code TEDI value. It can't just ignore that completely and result in a worse envelope. And another requirement is that the reference R values need to be derated the same way as the proposed. So it's not quite a pure ASHRAE or NECB reference model. It does have some other factors involved in it. And more details, again, are in the Vancouver Energy Modeling Guidelines. So that's some of the adjustments to the limits that came out of the step code. I wanted to talk about a few other notable changes that were introduced by the code. And so the second one I wanted to discuss is the Vancouver Modeling Guidelines. And I've already talked about those a lot in this presentation. And I mentioned them because they're sort of local modeling guidelines. They were obviously developed by the City of Vancouver as they were first testing out this target-based approach. Like Adam mentioned, UBC is a great sort of a hotspot for testing out new approaches, and Vancouver with their own building code also do a fabulous job of trying out new approaches that can then get adopted at a larger scale, like by the province. So they basically developed these modeling guidelines as they started their target-based approach, and they've now been adopted by the province for all step code projects. And they're currently in version 2. And they include a number of things on the energy modeling input side. So I mentioned earlier that there's a default air tightness to use during design, or at least a recommendation for not exceeding that air tightness. And that comes from the Vancouver Modeling Guidelines. And then there's also ways on evaluating results, interpreting results, such as the mixed-use buildings I was just talking about. So all of that information is actually coming from the guidelines, which is referred to directly by the step code. It's not a super onerous document. I think it's less than 20 pages, but it is specific to this code and to these metrics, which is really helpful. And the other thing is that the step code actually says that if there is case of conflict between the two, then between the Vancouver Modeling Guidelines and NECB 2015, which is actually the base standard behind all step code modeling, then the modeling guidelines will supersede. And so what's really nice about this is, like I've mentioned before, we kind of have this feedback loop. We're able to talk to the people who wrote the code and say, look, this is working or this isn't. And they can reach out to the community when updates are required. And it also can kind of update on a little bit of a faster schedule if necessary. So that's been really, I think, a benefit that we've seen to step code modeling is having these guidelines. Another notable change from previous modeling is the building envelope thermal bridging guide. So this was developed by BC Hydro and a number of partners. I've just shown a screenshot there of the cover sheet. And I won't go into details because I know modelers here will understand what thermal bridging is, but it's basically, I think the biggest thing is it's a consistent way of everybody to account for thermal bridging losses. And it's really getting that discussion in early days with the design team, because the modeler is saying, look, this is now absolutely mandatory. So it's making people think about, installation details right from the start, which conversations weren't necessarily always happening in early days design discussions. The fourth notable change I wanted to bring up was air tightness testing. So this was already fairly common for Part 9 buildings. However, for Part 3 buildings, it's actually still, I would say, fairly new. There's definitely a lot more practitioners coming on the scene, but it did require some capacity building to get to there, and I think it's fair to say that it's still underway. We have noted some growing pains as some Part 9 providers switch to Part 3. As I alluded to earlier, there are differences in the protocols for Part 9 testing and Part 3. The one obvious one being the test pressure, but there's also just a whole bunch of other requirements given that Part 3 has to follow along with the ASTM standard. So I just popped this in here, but there is another, we, for example, are giving a presentation on it in a few weeks, courtesy of Fortis BC, who's recognized again that you know, we need to be building up this capacity and getting more people familiar with the process of air tightness testing. So there's a lot more information coming, I think, regarding air tightness testing, and it's an area of growth in BC thanks to the STEP code. One of the things that I mentioned earlier that is really big related to air tightness testing is that the results have to go back into the model for steps 2+. And so as a result, we're seeing sort of two things come out of this, one being mid-construction testing. So while the air barrier is still accessible, doing some sort of testing to see if the project is at least on track. And also on our projects, at least, we're promoting bigger buffers on TEDI limits. I talk a lot about TEDI because it's the hardest limit to achieve. And so that one, you really don't want to be getting pushed over the limit right at the final post-construction stage, obviously. So we tend to push our project teams to go in with bigger buffers so that we're more likely to comply once the air tightness result comes back. So the fifth and final sort of notable change that I wanted to talk about was this Part 3 step code report. And I should say that, again, this is kind of the Part 3 focus, but Part 9 already has a report that is standardized and submitted to the jurisdictions. So they were kind of there along, like, quite a bit ahead of us. And I guess that's why it seemed more notable in the Part 3 world that the standardized reporting is being requested. So I put report in quotations because it is called a report, but it's really a standardized provincial form for Part 3 buildings. Again, it's available on the STEP code website. It's in Excel in beta version. And the reason I put it in quotations is it's not actually replacing a full energy model report that describes, you know, the inputs and the results of the model. It's really just a form that captures some of the key STEP code characteristics. So it is looking for some of the inputs to the building. And then also, of course, the energy results and compliance. So it's a form that jurisdictions can adopt optionally if they would like. It's definitely recommended if they choose to require STEP code in their jurisdiction. And just like the STEP code itself, the intent of the report was to clearly summarize the results and enable better consistency. So consistency between projects done by a particular modeler, consistency between different modeling teams, whether different companies or whatnot, and also just between jurisdictions. I mentioned earlier how before the STEP code itself, jurisdictions all had their own, or many jurisdictions had their own way of requesting projects to exceed the code. One thing we've seen come out of STEP code is that different forms have popped up, and some focus a bit more on the input side and some focus more on the results, and some miss a few things here and there. So this nice standardized report is a great way, again, to just get consistency across the province so everybody's starting to provide the same product. And the last note, the intent of this document is to enable the province ultimately to collect uniform data that can then inform and improve future codes. And so this is just kind of a little glimpse of what's to come, but the province has been working for a few years on a provincial online energy reporting tool called BERT. And it's going to be an online submission tool that will supersede both Part 9 and Part 3 checklists, as well as the ASHRAE forms. So if you've worked in BC, you may be familiar, or in the Vancouver building bylaw jurisdiction, you may be familiar with having to submit ASHRAE Part 11 forms or or whatnot during various stages of submission. And so this tool is intended to supersede all of those items, and then of course collect all of that data and then inform future codes. And so I think that actually is kind of a nice little tie into tomorrow's keynote presentation about closing the feedback loop. So I'm personally quite excited as to seeing this tool come into play. It was supposed to be out spring of this year, but COVID unfortunately had a pretty big impact on it last year. So from what I understand, I talked to someone a few weeks ago at the province, and they said that part 3 is going to be released first, and it's now anticipated for next spring. So that will be a great opportunity for data collection there. Okay, into the next section, which is looking at how the STEP code has impacted design and practice, and some successes and also sort of lessons learned and challenges that are still working at being addressed by the STEP code. So I wanted to start by sharing how has this sort of changed design. And so this is just based on our projects, so Focal's projects. We have nearly 100 underway since 2017. 40 plus of those have achieved building permit. And so our team went through and we data mined just over 40 of those projects. Of course, they're anonymized. Obviously, this isn't the largest sample size, but given that the projects have been around, or sorry, the STEP code has only been around for 4 years, it's not a bad group. And the other thing I just keep in mind is that since we were looking at building permit level, these tend to be our earlier projects. So some came into play under some of those earlier versions of the STEP code and the earlier versions of the modeling guidelines. So this is just a quick summary of the projects that we were looking at, and that gives you an idea of which projects are kind of looking at STEP code. So here we have them sorted by climate zone. So we included 4 to 7, and there's 41 entries total. You'll notice that the next couple slides, we're actually going to drop off that climate zone 7, that one project. But we did have 41 that had crossed the building permit line when we pulled this data. A couple of notable things. First of all, most of them are occurring in climate zone 4. So it is, I think it's fair to say, easier to achieve STEP code in the warmer climate zones. So not surprisingly, we see most of our projects here. Although I'd also argue that, we have much greater population density and much more new construction projects occurring in climate zones 4 and 5. So that would be another reason why we're seeing so many new projects in these two climate zones. The other thing that I think is notable is that we only have 4 projects out of 40, so 10% are hitting those lower steps of steps 2 and 3. The majority of them are step 3 projects, and then we have 8 going for step 4. And again, just a reminder that these are just our part 3 projects that we're looking at. We do have some part 9 passive houses and those kind of things, but we didn't include those in this analysis. So I don't have full reasoning behind this, but it could be related to, I know there was a campaign, we were a part of it, called 3 for All, suggesting that jurisdictions should jump straight to requiring step 3 and ignore the lower steps. So potentially that campaign might have had some impact in seeing all these step 3 projects. It also could be that the jurisdictions that are leading the way and adopting STEP code upfront, or projects that are voluntarily choosing to go STEP code, because that's always an option too. Even if it's not mandated, a project could choose to achieve a higher step. Those are kind of the early adopters. They may be the ones who focus more on the higher steps. And then as the building code sort of requires that the minimum compliance levels get better and better, that's when we may see more and more step 1 and 2 projects. So that's just my own interpretation of this. There could be other reasons out there as well. So from this data set, we could go way into it, but I just pulled a couple of, or just 2 inputs to share with you today. So the first one is looking at the effective wall R values. So this includes the thermal bridging according to the thermal bridging guide. So first we can see the dots show the average for all the projects within that climate zone and step. And then the bar is the range of entries that we saw. So not surprisingly, as we get to higher steps within a climate zone, the effective R value goes up. Here we're seeing an increase from roughly R15 to R25. And similarly, if we look at step 3 and we get into colder climate zones, we see the effective R value going up. So I think what's maybe telling here is that we are definitely seeing higher R values on the step as the steps increase, but we're not seeing too much increase over the colder climate zone. So while we do need to put some thought into it, it doesn't seem to be a barrier to entry, essentially, to do a step 3 building in a colder climate zone. Some projects get up to maybe R27 effective, but we have at least one project here, that's less than R20 effective, and they may have other strategies, or they must have used other strategies in order to achieve step 3 in climate zone 6. Similarly, I just wanted to look at the heat recovery SREs that we're seeing across those same buildings. So same trends, in climate zone 4, the higher step we get, we're seeing much higher SRE. But I think again, what's kind of interesting is ignoring steps 1 and 2, we're basically just seeing heat recovery around that sort of 75 to 80%, pretty much across the board. There's one project here that had no heat recovery in step 1, and so that's why we see this bar down to the bottom. But if again, I think what we're seeing is that it's becoming the norm to adopt heat recovery. Higher levels are achievable, and hopefully that's also then improving price points for equipment and installers and maintenance folks getting used to this type of equipment, and it no longer being something unusual. It's just kind of par for the course. So how have these kind of inputs affected us on the results side? So these are the results for those same buildings. So the colored bar is the target or the requirement, and then the gray bar is the average that was actually achieved. So that step 2 building, there's just one of them. If you look at it in climate zone 4, it actually would have easily achieved the step 3 TEDI. So although it was only required to hit step 2, at least from a TEDI perspective, it could have gone to step 3. So we could have even bumped it into that category, further reducing the number of lower steps that we had in this example. But we can see again that all of our projects are seeing, are at least going in with a fair buffer on the TEDI, which again is the more challenging metric at the building permit stage. And this again relates to what I was talking about before, how with air tightness results needing to come in later, we want to make sure that we have a buffer so that we don't get too surprised down the road when we actually put those results back in. Again, if we just look in the climate zone 4, sort of one of the notable things we can see is that our buffer gets smaller as we get into the higher steps. And that's something that we've had a lot of discussions for clients, is that, when you start to get into these projects with smaller and smaller, sorry, I'm just having a blank moment there, smaller and smaller energy budgets, then essentially we need to really tighten up our designs earlier in the design process. And so what we see is that we're looking at things early in the design stage that maybe wouldn't have usually been conversations at that point. So things like air tightness, what kind of air barrier will we be using? How are we be detailing that? Thermal bridging, what's the installation going to be for windows and major connections and those kind of things. So these buffers are basically something that are starting to push those conversations earlier in design as well. So on that note, what are some of the successes that we have seen thanks to the step code? Well, as I was just talking about, the TEDI really has been shifting focus to the envelope and shifting those conversations to the envelope as well. So the thermal bridging guide, like I mentioned, has given us that kind of consistent way of evaluating thermal bridging for energy models. Also, just having, for those of you who aren't aware of the guide or haven't used it before, the appendices provide pages and pages, hundreds of pages of sort of typical details and what those values would be associated with the details. And so in those earlier conversations, we're able to point to a couple of details and say, look, which one do you think we're going to achieve, and use sort of a real number rather than just estimating off the bat. So just having that level of consistency and to bring to the design table right at the start is really great. Similarly, I've mentioned it before, but the air tightness testing has also got designs looking at air tightness and infiltration earlier on, but also just brought that conversation to the forefront. And as I mentioned, heat recovery on ventilation is really becoming standard practice. Elsewhere in Canada, it may have been adopted a little bit earlier, but for us, it's becoming just the norm, basically, for ventilation here. Another item that I haven't touched on as much yet is the Part 3 overheating limit. So looking at that summertime internal temperature and whether it's remaining within sort of a comfortable range or not. And so that limit is really bringing the thermal comfort discussion to the foreground. And that's having a few implications in sort of future research work that's going on that I'll talk about in a couple of slides. But even for today, I know that everybody's kind of being, thermal comfort has been considered in various ways and standards for a long time, especially as far as, mechanically cooled spaces, but it's really heightened the intensity of the discussion for passively cooled spaces. I've alluded to this a little bit, but thanks to these more challenging energy requirements and tighter energy budgets, oftentimes the modeler is brought in earlier in design in order to get those conversations on the table. A lot of times we're asked to, review designs, not even to do a model at early stages, but just to kind of highlight anything that might jump out at us that could cause problems later on. And then I also mentioned this earlier, but having the City of Vancouver modeling guidelines, these local sort of guidelines and the quicker feedback loop has been really beneficial. Even being able to call up the person who wrote them and say, look, are we interpreting this correctly? Is that what you intended? That's been really wonderful as well. So those are some things that we've really enjoyed working about working on step code models. Not surprisingly, of course, all new things come with challenges as well. And so I'm going to dive into a few of those. I've talked a lot about the tidy metric and it being intended to be an envelope metric, but it does include that ventilation and heat recovery component. And while it's great to encourage better heat recovery, and like I said, it's resulted in lots more standardized heat recovery in industry, including the two together means that you're never really evaluating one or the other. And so what we see in some projects is, spending a little bit extra money on the ventilation, heat recovery, and then letting the envelope side slide. So that can be one downfall to having the one metric cover both entries. The other one is, of course, when we are actually trying to focus on, when we get into buildings that are ventilation driven and that maybe don't have such a big envelope component. So for example, hospitals, those ones, have major ventilation requirements and very clear boundaries as to where there can be heat recovery and not. Of course, envelope is still important because if you have people stationary in beds by a window, you want to make sure that they're comfortable. But envelope isn't going to be the driving factor for energy performance. And so that's one of the ones currently under consideration. You may remember I introduced it back earlier that there's this new group of public sector buildings that have step 1 requirements only. And there have been discussions this past year that we've been involved in on can we introduce, TEDI metrics for things like a hospital. And that is one of the areas that the metric is determined to be quite weak is that it may not be the best representation for that kind of archetype, for example. Another area that has been a challenge is small buildings. And so, of course, when you talk about an EUI target or an intensity target, smaller buildings with their smaller footprint, they get a much smaller energy budget. And arguably, they are more efficient because they're smaller. They're using less land, less materials, etc. The step code adapted to adjust some of the requirements. I showed you the Part 9 calculation, how the heating degree day gets kind of linearly interpolated. That's for smaller buildings, for Part 9 buildings. So there's also some kind of floor area components that come in there as well. But then if you're increasing the energy budget, the argument goes, well, now are we still, or do we still have a code that is as stringent as we want it to be? So small buildings definitely can pose a bit of a challenge with these kind of target-based approach. Similarly, flat buildings with a lot of envelopes. So we worked on a gas station, for example, that was mandated to meet step code under the retail category. And you can, your gas station isn't your typical retail building. It's got different types of loads, different types of, I think we had some ventilation because, they have a bit of a kitchen component with something they were heating or cooking back behind the scenes. And so, and then they also had, lots of envelope. A gas station is not something that you're just going to see under a multi-unit residential building. So that one was really quite challenging to pass, and yet it was mandatory. So we had to work with the team to get it there. There's also been some growing pains along the way. So I mentioned the air tightness requirement that was in the City of Vancouver guidelines. And the version 1 of the guidelines actually had a varying schedule for air tightness. And then the version 2 of the guidelines came out and gave us a standardized schedule or a standardized rate that should be applied at all times. What we're actually finding on our projects is that depending on the type of air barrier that's employed on the project, is that version 2 actually can be too stringent. And some projects are testing at the end and not meeting that requirement. So just kind of blindly following the guidelines doesn't necessarily work. You have to take that experience back into the picture. So although there's that kind of downside that the versions have needed to update, at least they haven't had that ability to do so. And then the last kind of challenge I wanted to bring up was when we have buildings with an unusual element. So for example, if you have a care home that falls into the residential archetype, oftentimes they'll have smaller bedrooms and they may not have their own kitchen. Instead, they have a commercial kitchen where everybody eats and all the food is prepared. And so arguably, you've got the same number of people eating and cooking as, say, an apartment building. But because you're now taking all that cooking and condensing it into one location, you have commercial kitchen ventilation requirements. And so that can then, again, going back to that Teddy being a challenge because it includes both envelope and ventilation, something like a commercial kitchen can really throw off your calculations. Okay, and the last challenge that I wanted to bring up, so this is something I actually just came across in the last couple of days, so apologies that I don't have too much background on it. I haven't been able to talk to anyone on this particular subcommittee. So I'm on the Part 3 subcommittee that advises the Step Code Council on technical recommendations for those building types. However, there's also a Part 9 subcommittee that does the same thing for Part 9 buildings. And they had a meeting on June 3rd. So again, this is very recent information, not even 2 weeks ago. And they put forward this motion to the Step Code Council. Apologies for all the text, but I just wanted to copy it verbatim because, again, I don't know the details behind it to kind of summarize. But they basically said, given that, the step code is supposed to put us on a target to be net zero energy ready by 2032, we also have Clean BC requirements of homes being 80% more efficient than the current baseline by 2032. And thirdly, BC and Canada have committed to the Paris Accord. The committee then wanted to inform the STEP Code Council that the BC Energy STEP Code as currently enacted does not enable Part 9 residential buildings in BC to achieve the goals of the STEP Code, Clean BC, or the performance outcomes aligned with international norms. So basically, they were saying that, you know, the current STEP Code is not meeting these 3 requirements. And they're sending that back up to the Energy STEP Code Council. And those are the folks who actually administer the STEP Code. So not meaning to put a damper on things, but I think it is worth, you know, really noting that this is a group of technical experts who have been advising the committee, the council from the start. And here they are saying that we're not there yet. So there's definitely still work to do. So just before I jump into some of that work, I wanted to share a little bit of an impact on the practice of the STEP Code. So to do this, I sent out a modeler. I put survey in quotations because I just sent it out to a dozen people. It was pretty quick, but I just wanted to see, were other people seeing changes in practice the same way we were? Because I know what's happening to our practice since the STEP Code came into play. I just wanted to see if it was relevant to others as well. And when I just, to put this into context, when I stopped being chair of ABIPSA 3 years ago, we had about 100 modelers. And so 12, and I got response from 9. So we're looking at about a 10% representation there in BC. So, so that's the BC chapter of ABIPSA. So even though it's a smaller number, it still was hopefully a little bit representative. What I was really looking for was how did the STEP Code change modeling practice, like I said, beyond what we've been seeing at Focal, and then whether people like it or not. So here we go. This is just looking at before and after percent of work. So I asked people what percentage of your work was made out of STEP Code, code compliance, green building, rating, incentive program, or other. And this is from all respondents. There were 9, and 3 of them actually weren't working with the STEP Code, so I did a subcategory excluding them. And when I said before and after, I said, okay, roughly think of your practice around 2015 versus think of it last year in 2020. And so in both cases, what we saw is that, not surprisingly, code compliance is going down once the STEP Code is adopted. So the STEP Code is has taken on some of the code compliance modeling. So that I would expect, since it is a pathway to demonstrate code compliance. But the other piece I was kind of wondering about is what we're seeing. We used to do a lot more lead models, you know, for green building rating. And we're seeing more adoption of the STEP Code, I think, in lieu of some of those models as well. So that's this green bar decreasing. And it turned out others were also seeing the same thing. So those, I think, were kind of the more notable changes from before and after. The other and the incentive program were remaining fairly consistent, which is what we saw. And so I was kind of wondering if others were seeing the same thing. When I asked folks how do they like it, greater majority said it is better or much better than having a reference model. So using the reference-based approach under either ASHRAE or NECB. And I asked an open-ended question of why, and then I kind of pulled out a few similar responses. So the most consistent response I got was, hey, there's no baseline or reference model. So a lot of people definitely felt that that was preferred. And then I think leading from that is, without having a reference model, we get to focus on the proposed design. And I too prefer to focus on making the actual building we're building better, rather than kind of playing around with trying to make a reference model appropriate. Again, in line with that, there's less time and effort because we're not doing that reference model. And a couple of other items just that folks responded on was, it's a nice clear pass or fail. You know, you either hit your TEDI or you don't, you hit your TUI or you don't. That's also really nice for client communications, I find. Improved consistency, the building envelope component, you know, getting that discussion in there, that consistency. The City of Vancouver Energy Modeling Guidelines, they're specific to this type of model, which is really great. Addresses overheating, and then involves modeler more in design. So those are some of the feedback that we got. as to why people are preferring the step code these days. Again, in that smaller sample size. Okay, lastly, I wanted to just touch on a little bit of ongoing work that is currently underway, as well as anticipated changes that we expect to see on the step code. So the first one I've mentioned already, overheating is currently evaluated for passively cooled Part 3 buildings. However, there's lots of groups out there, and I know UBC and I think UVic also are involved in these discussions as to how to better evaluate overheating in passively cooled spaces, as well as maybe mixed mode spaces and mechanically cooled spaces. So this involves updated metrics, one's looking at thermal comfort, and then of course building on existing standards. So using more of ASHRAE 55 and looking at other standards like SIBSI, etc. And then related to this overheating analysis is of course the idea of continuing it into a future climate analysis. So the overheating, I think, is kind of a foot in the door into the conversation of adaptation and resilience, and making sure that our buildings can really survive into the future climate without requiring upgrades immediately for thermal comfort reasons. Like I said, there's lots of ongoing projects with various folks involved, as this is, I'll put my favorite pun out there, this is a hot topic right now. So in tangential with the overheating analysis, you know, in order for models to be able to look at future climate, we need to be able to model future climate. So we need future weather files. So I'm sure many of you have looked at the International Panel on Climate Change future climate scenarios. They project one of these three RCP scenarios depending on how we do on reducing our greenhouse gas emissions. Unfortunately, Adam introduced us at the very beginning that we may not be not there yet. However, what we've done is the Pacific Climate Impacts Consortium, PCIC, has come up with future climate files in BC for each of these three scenarios in over various different decades. And so a lot of modeling is being done right now, particularly with step code, looking at those future scenarios and seeing how that impacts both energy performance, but also thermal comfort. And so here's just an example from that Vancouver, or from one of those files for Vancouver. So if we compare it in gray with the CWEC 2016 file, how does that shift into the 2050s RCP 8.5, so the worst case scenario for Vancouver in 2050s. Another item that is kind of related to this overheating conversation and future climate is cooling energy efficiency. So right now we focus a lot on heating energy efficiency being heating dominated climate, but we really want to make sure we avoid unintended increase in cooling energy due to inefficient design today. So I alluded back earlier in the presentation to a Part 3 report that the province has created that asks for consistent submissions of step code models. And they've actually included this new cooling energy demand, again, so that they can kind of start tracking it and potentially develop it into code later on. So it's not a code requirement yet, but it is something that if you fill out that report, you'd be asked to submit. And I think what's interesting is that, yeah, it just gives us that ability to start tracking things before they're in code, so that future codes can then consider whether that would be something relevant to consider. And then just a list of other kind of coming changes and considerations. Again, on the Part 3's step code technical subcommittee, we're looking at things like greenhouse gas intensity. Should that be included in the step code, and requirements, limits being required for certain buildings? How about other occupancies? So I mentioned those 6 public sector building archetypes. Should limits be brought in for all of them or some of them? And if so, what limits? There's studies been done on that already, and there's been some consultation on that, but that's an ongoing conversation with the province. A whole other world is, of course, existing buildings, and how can step code be applied to that when upgrades are being done. And of course, we anticipate future energy modeling guideline updates from the City of Vancouver as well. So lots of things under work. And finally, the whole point of the step code, as I introduced from the very beginning, was to outline these steps that future codes will adopt and increase the baseline on. So, you know, base BCBC is intended to eventually become step 1 and then step 2 as we get on our pathway to net zero by 2032. So we anticipate that, you know, we never know for sure, but we anticipate that those steps will later be adopted as BCBC as we move along. So just wrapping things up here, we have certainly seen step code changing models, projects, and the process of modeling in BC. There have been lots of successes, thermal bridging, air tightness testing, this great data collection opportunity, and earlier conversations about modeling in design. There's still lots of ongoing work, such as the new building types, overheating, adaptation, and resilience. And then I still pose that question, are we doing enough yet? And I'd love to hear feedback on that if folks have experience with the step code. One last thing that I'd say that I really appreciate about what the province is doing is that they take the approach, let's do it and then make it better as we go. So overheating is a great example of that. It's in the code. We realize that we're not yet at the end goal. The current metric isn't doing everything that we want it to do, but hey, it's getting those conversations going. It's initiating all these research projects, and it's you know, it's taking the step now so that rather than getting that kind of analysis paralysis of trying to figure out the best approach right from the start, it's at least engaging everybody in the conversation and getting things started. So I think that's another really great outcome that we've seen from the step code. A couple of resources, if anyone wants to look at a lot of the images that I had from the presentation or from the step code website, reporting resources that I've discussed are available there. And so that's energystepcode.ca. And then we have a couple of resources as well as our own on our own website, a few adjustment calculators on there, as well as our team hasn't quite finished a paper yet on those findings that I was sharing with you as to what our values and what HRV SREs we're seeing and those kind of things, but that will be up on our website again soon as well, if anyone's interested further. So again, thank you everybody for joining today, and thanks again to the organizers for getting this going. Looks like I didn't leave time for Q&A, but here's my email, so if anyone does want to chat at some point, please feel free to reach out. I'd love to hear from you and hear about your experiences on this or similar codes. So thank you.